I'm thinking about the Ray-Ban glasses. I'm thinking about the new project by Meta, the Meta or Ions glasses, where, 100 grams only, like basically as light as a real glass, but you have holographic glasses that are context aware, that are able to be an extension of your cognitive skills. They're able to track your eyes. They're able to answer questions like, what is this monument that I'm seeing in front of me, and giving you real-time answers.
Right, we are live. So I wanted to first welcome everybody to our latest episode of Facing Disruption's Future of series, where we explore how emerging and disruptive technologies are transforming industries, society, and impacting our everyday lives. Our mission is to uncover unique insights and strategies to help you to navigate and thrive in a rapidly changing world. And today, I'm really excited to bring my friend Giuseppe Barbalinardo, PhD, Head of Data and AI at Tonal. I've had the great fortune of getting to know him over the past year, and we have been going back and forth on lots and lots of topics that we're really excited to talk about. But today, we're going to focus on AI, human-machine interactions, how this rapid change of technology is forcing us to rethink how we're engaging with technology. So I'll stop there and give you an opportunity to give us an introduction on yourself.
Hello, everybody. Thank you, AJ. Thank you, Facing Disruption, for having me today. Brief introduction about myself. My background is actually in theoretical physics and software development. I've been interested in machine learning and AI for 7 years. The context initially was during my research, and I was studying, let's say, the microscopic world and how to use molecular particles, dynamics, simulations in the context of physics to describe new technology, and how to put together quantum mechanics and statistics to design, to discover new materials. And this is a pretty complicated task. You need clusters of tens, hundreds, thousands of cores to simulate collective behavior of particles. So during my PhD, some of the work that actually at the very beginning of the PhD I started doing was to how can you use machine learning, how can you use AI to describe this sort of collective atomic force that keeps together atoms. And this is something that now is a pretty hot topic. I mean, in the most recent month, actually last month, Meta has released one of their foundational models to describe the atomic forces. In the past few months, also Microsoft has released MacroSim, this great model to study electromagnetic thermal properties transferable over a wide range of materials. So if you want to design new technology at this point, you want to break the nanoscale barrier, you need to have a way to describe particles, atoms, and molecules at a nanoscale in a very efficient way. And AI machine learning is really revolutionizing the way we do that.
Yeah, I love it. And we're going to have to dive deep into that in our next conversation for sure.
Yeah, I just wanted to say, fast forward in the last 4 years, I've been working at Tonal. I'm currently head of data science and AI. And the application of AI here are more customer facing. And what I really like about this new adventure is that you really see the impact of AI and human machine interaction on hundreds of thousands of people. You can tackle big challenges. You can really solve big issues like increasing people's lifespan, increasing people's health span, addressing issues like obesity, improving our lifestyle, aging health, addressing problems like osteoporosis, sarcopenia, like reducing the reduction of the muscle density, the reduction of bone density. So there are a lot of fascinating opportunities, like finding the best way to communicate with humans and machines during a workout in a very stressful environment under pressure. So this is what I'm doing today, and I'm excited to chat more about it and talk a little bit more about human-machine interaction in this context.
And that's what really excites me about this conversation, is that you have experience on both sides of the equation. The deep technical experience building, operating, running, executing these machine learning models, doing the science behind it. But now you're really focused on, well, how are your customers interacting with that technology, right? And the usability and the behavior patterns that you really need to take the theoretical and then turn it into practical applications that everyday people can use. And that's, the topic that we're going to talk about today is, we have always interacted. I mean, for a long time, we've interacted with computers through various physical means of communication. So text, screen, so visual. We've done audio, of course. Now there's natural language processing. There's different modalities that we're getting into, but still we're seeing an evolution, because one of the things that I really have been exploring is, we have, as humans and as a society, barriers of communication with each other. So what are the barriers of communication that we have with technology, right? We wanted to do things and we can't always articulate our needs and our intents. So, the shift from passive AI responding to inputs, and now with AI trying to predict real world interactions. Tell us a little bit about your opinion on that, where we've been, where we're going, what you see.
Yeah, well, I love this topic. I think we're in this place where there has been this revolution through AI, and we have this wonderful technology, and the technology is becoming accessible to everybody, large scale, adopted. The question is it already like seamless? Are we already at a point that we can promote AI, use AI? Not only is AI accessible not only for tech people, are we designing AI in a way that like every person, every segment of the population can use AI? And the answer is not yet. There are still, if I think about my parents, for example, if I think about elderly population, there's still a little bit of barrier in accessing that kind of technology. So we're seeing a shift where AI is becoming more seamlessly integrated with our environment, and the human-machine interaction is really the key for that. We're seeing like a lot of wearables, we're seeing like glasses, sensors that more and more immersive, and are sort of like breaking this barrier and are bringing us to this next generation of communication between humans and machines.
Let's talk a little bit more about the examples and the ones that excite you the most. I've been working with wearables and immersive reality for a long time, so would love to hear your opinions of that space, and where do you see it going today?
How many minutes we have?
We have lots of minutes. Yeah.
These are very, there are a lot of great examples of great products in the world of human-machine interactions. I think some of the ones that really excite me, for sure, glasses, like going beyond the communication between using words, using voice to control things, going beyond the reading text, as you were mentioning before. I'm thinking about the Ray-Ban glasses. I'm thinking about the new project by Meta, the Meta or Ions glasses, where 100 grams, only like basically as light as a real glass, but you have holographic glasses that are context aware, that are able to be an extension of your cognitive skills. They're able to track your eye. They're able to answer questions like, what is this monument that I'm seeing in front of me, and giving you real-time answers. And there are like also some new ways to control them. And together with the glasses, Meta is also releasing this very cool project. There is a wristband that is based on SEMG, so surface electromyography. And the idea is that you can control, you can scroll, you can pinch, there's haptic feedback, and the way it's done, similar to when you do measurements, we actually do something to phone where you use electromyography to measure muscle activation. This is done at a surface level, so you can really understand, using the difference in the electric potential on the skin, the movement that the hand is doing. So imagine like the potential that this allows us, like if you had to say, scroll up or scroll down, it takes some time, but if you have just a single movement, a single snap of the finger, it really improves the speed, the performance of our interaction.
And that's an evolution of what we've seen before with some of the gesture bands that were out there, right? SEMG, as I understand it, is really looking at the activation of nerves and muscles in your arm, and it's able to now look granularly to see, hey, what are you doing at a very, very detailed level, and then how do I translate that into an action, right?
Yeah, exactly. And AI is really playing an important role in converting these activation signals and voltage signals into features that are then processed into our other AI models, perhaps. I was thinking another example, like the AirPod Pro. Currently, not everybody knows that there are already a lot of sensors in the AirPod Pro, the accelerometer, the gyroscope. There are apps on the App Store that help us, if you're leaning too much forward, they tell you, like, adjust your posture. They do it through the accelerometer and gyroscope. There's a recent patent from Apple that is including like more sensors. We'll see if they actually end up realizing that, but the idea is to read electromagnetic waves from the brain and create feature from them. So there's going to be monitor brain, muscle brain, heart activity, monitor brain, monitor muscles, monitor heart activity, all in a single small piece of technology like the AirPod.
Yeah. And with all of that, I'd imagine, this is increasing the bandwidth of communication between us and the AI or the technology that we're trying to interact with, right? We're not dependent. How fast can you type? How fast can you read? You mentioned that earlier, right? It's, in essence, we can communicate with the technology faster. And one of the things you and I talked about before this was, then the logical next step is, well, how does that become bi-directional bandwidth increase, right? How does the technology begin to communicate with us faster? And I don't know if you have any, examples of that you're seeing.
Yeah, absolutely. I mean, you can go to the extreme cases, like, Neuralink, where you have a brain-computer interface. I'm thinking, the N1 implant that has 1,000+ channels that communicate. Still, like, at a research stage, but already you can measure neural activities at a very high resolution. You were talking about the bandwidth. We think about the way we communicate with voice, like, or the way we read, like, there are limitations there. You can talk 2 to 6 words per second. You can read like 3 to 5, 6 words per second. So there's a limit there. When we talk about these new glasses that allow you to see images, you're really like going to a different dimension of bandwidth, different dimension of how much information per second you can deliver. And again, the wristband with the haptic feedback that allows you also to go much faster for certain tasks.
So you mentioned a little bit of how Tonal is integrating some of this. I wanted to give you an opportunity to talk about that.
Yeah, absolutely. I was saying at the beginning, Tonal, one of the places where to study some of these technologies, where we work a lot on human-machine interaction. Just to provide a intro, Tonal is a whole gene that fits anywhere in your house, and you have your AI personal trainer that is allowing you to live safely at any time. And the AI is trained to help you achieve your goals. And great, the brilliant idea of the founder Ali Radi when he started the company a while ago is to not use a rack of weights to work out, but to use electromagnetic resistance. So not only it affects how small the form factor is, much smaller than huge rack of weight, but it's also like allowing you new ways to do workouts. So you can have some specific resistance profiles, stimulate some physics like lifting chains, for example, or fixing the velocities instead of fixing the weight. So there's all these new ways to do workouts or to do exercises. And then there's the way for you to communicate with the machine that is completely new. So in fact, it's not anymore, the coach then look at you and tell you like, okay, this is the 1 rep max that you can do, like the maximum strength that you can do in this movement, like a bench press. But now you have this fully immersive environment made of sensors that connects with the smartwatch, connects with the table data that can tell you from the measurements in the motor. It can tell you like, this is your range of motion, this is your speed, this is your strength at this specific place in the range of motion, and so on. And there's also, of course, there's a camera. So there's a smart view camera that gives you all the information that, computer vision can give you. So, for example, if you're doing the movement, having a poor posture, there's a feedback loop that tells you like, okay, you should not bend, arch your back when you movement, because that's going to be bad. That's injury prone. So there's a whole study on how, first of all, how the machine should interact with the human, but also on how you deliver the feedback, because you are like in a particular situation when you do a workout. You don't want to have cognitive overload. You want to have the specific cue that can be, visual on the screen, that can be audio cue, that can be visual at the end of the workout. So this all thought process on what is the best way to communicate is part of the study that we, of course, people like behavioral scientists that do this work. So yeah, the good part about this sort of research is that you have a lot of data. And we're talking about the sensors. Tonal has the largest strength data set in the world. There's like, I was thinking about 2024, I had some data here, like there were more than 10 million training sessions, 1.8 billion repetitions. If you think about weight, there were like 70 billion pounds.
Oh my God.
2023.
That is a really interesting way of putting it. So I'm hearing, you mentioned predictive AI earlier, and I'm gathering that there's like 3 pillars to where we're heading with it. There's the predictive aspect, because you're able to collect in near real time, almost real time, probably real time information. So the predictive is it's collecting more signals than you're consciously aware that you're putting out. It's reactive because it can then analyze that and make decisions to change your behavior or implement some action. But then it's also proactive to what you were saying of, hey, I see you bending in a certain way, and based on these measurements where I see your body going, or I see your behavior changing, it can now shape your behavior to nudge you out of it into something better, into a better position, into not pushing or into pushing harder, right? It could be your coach, like, keep going. I know you have a reserve of energy left.
Yeah, absolutely. And I like how you describe these. There's one thing that speaking of like, the real-time component, then it goes like at different levels of, from the real time component to all the way to, you have an objective that you want to, you have a goal for your next 6 months, and how do you create the progression for that goal? I'm thinking, when I joined the company, one of the part that was fascinating me the most was like, okay, I want to do workout at 4 a.m. in my garage and do it safely. I don't need to have like 3 friends that help me doing the spotter. I have just a machine that is intelligent enough that is able to understand when I'm struggling and reduces the weight safely. So that's something that, as we were saying, like in terms of like real time and being reactive, like that's something that really needs to happen very quickly, needs to happen very precisely. And, there's very specific kind of machine learning that you can use at the time scale, and you need to be paying attention on like all the complexity of running things on the edge, because you want to have like this happening, it cannot go all the way to the cloud, needs to be very promptly reactive to the user. On the other hand, there are the opposite scale where like setting a goal, then you want to have some sort of like initial design of your path towards that goal, and then adapting along the way.
And that's where the behavioral scientists come in to help. You mentioned that a couple of times, and I'm really glad that you do, because that's something that I've talked about a lot is, we tend to focus so much on the technology capabilities. At the end of the day, there is a user, a customer, a client. There's somebody is ingesting that capability and taking action on it. So, tell us more about, the role of the behavioral scientist, the challenges in developing these intuitive AI interfaces.
Yeah, I mean, there's a whole team of time actually that works with us and help us design in both the short term, the immediate feedback, and the long term progression, and how to achieve your long term goals. I think more generally, like, there's 2 things that we need to be aware when we design a new technology. One is how to make it easy. So we were talking about, for example, how to make what in a stressful situation, like while you are doing a workout, how to make it easy to achieve this sort of like 2 ways communication, and how to make it accurate. Because let's not forget that, like, yes, on one side, when you learn to do how to do a deadlift, when you learn how to do a squat, the right way, then it's portable when you lift your grocery bags. But on the opposite side, if you learn the movement in a poor way, at the minimum, you're transferring that knowledge to other times that you do similar movement in that movement poorly. It also can be worse. It can be injury. It can cause injuries, right? So you need to make it accurate. You need to make sure that your models are trained in the right way. You need to make sure that your algorithms are designed in the right way. You need to make sure that there are guardrails. You need to make sure that, like, if you're working with health, for example, what kind of knowledge are you feeding your system? What kind of knowledge are you using to feed your system? For example, now we think about large language models. You can't just take a large language model out of the box and use it for health prediction, because that has been trained on the whole World Wide Web. Reddit has been trained on all the possible ideas that we see on X, the Facebook. Like, you need to have a way to introduce guardrails. You need to have a way to understand how the AI is thinking behind the scene, and monitor that and control that.
You gave me this image in my head, thinking back to how much work is being done for engineers to train models, and then the way that you were describing coaches is like, oh, now AI is training you as the model. Do it this way, do it this way, do it this way, until you begin to get it. It's a very similar process from one to the other.
Absolutely.
I like that. One of the things that you had mentioned previously was around HMI and chain of thought, and how that facilitates future interactions. What are the implications there? So can you get a little bit into that? So when you say chain of thought, what do you mean by that? And then talk about HMI's implications there.
Yeah. So speaking of AI guardrails, and with guardrails, we can think about the health specific case that I was mentioning before, but more generally, there are like plenty of that we need to introduce when we think about AI. The ethical guardrails are another big example. How do you, and these models now, like, give you the possibility to see exactly how, what was the behind the scene thinking. At least some of these models allow you to break down the thoughts behind the main response. And you can control these, creating data sets for controlling each one of these single steps. There are libraries that help you doing this structured decision making. Like I'm thinking of LangGraph that is based on Banshee, Pydantic AI, model context protocols, and there is a way to make the not only the output verifiable, but also the way you got to the output and verifiable and testable.
And we talked a little bit earlier about the risks of AI deception and bias amplification, and you talked a bit about the importance of putting guardrails in. So it wouldn't be a conversation about AI unless we dug into some of those ethical considerations. And you mentioned a few of them, right? Getting these general purpose models that are trained on such a wide array of data that you really aren't able to verify it at scale. You have to begin to train on purpose-built information.
Yeah, absolutely. We need to talk about ethical considerations and bias. I'll start with an example. What happens if you ask ChatGPT or DALL-E to generate a picture of a watch? What do you think is the time that will be shown on that watch? No idea.
Tell us. No idea.
10:10. And the answer is 10:10. And the reason is because at some point, watchmakers realize that if you show the watch at 10:10, it looks a little bit more beautiful. So they started producing all these images of watches that show the time 10:10. And then the AI has been trained on these images. So now you ask AI, they ask any ChatGPT, any system to generate a watch, and it shows 10:10. Now, this is a very simple example of bias amplification. There are much more complex examples. For example, imagine if this bias was towards the skin color or underrepresented areas of this world. There's a whole awareness that we need to have, and there's a whole work that we need to do in order to make these systems safe. That's there are deception problems. I mean, now that we have these AI systems that have like more complex chain of thoughts, there was a beautiful study recently from Apollo Research. It was called Skinny Reasoning Evaluation, and they were doing all sort of tasks to AI, giving a goal and trying to understand when AI was lying to humans. So there's an AI deception risk, and of course there are also like human risk. I mean, I was thinking about Grok 3 recent release. There were like some comments on the fact that like it was manually, the prompt was manually updated in order to avoid in certain cases to answer to the question whether or misinformation. So that said, like we need to be aware, and we need to be actively, constantly trying to avoid these sort of biases when we train the data, when we use the models, and rely perhaps on open source models that allow us to see what's behind the model, what's the weight There are, Llama by Meta, Mistral, DeepSeek that has also the way to allow people to and the chain of thought. So really, there are solutions in development in that direction.
Yeah. And I would imagine that with any technology, the implementation and execution also is susceptible to bad actors, right? As I'm thinking, with technology being able to sense so many different aspects of your physical, mental, emotional state now, is there a risk of deception where you can identify when somebody is in a state where they can be easily influenced? They're stressed out, they're tired, they're, whatever it is. And now you could begin to insert subliminal messaging. I think this is a topic for another conversation, right? We're diving deep into hyper-personalized things. But yeah, that gets into some of the risks that we're talking about, right? The risks that come along with this technology and having that much information.
Yeah, I mean, you're right. You can use AI for bad purposes. There's some effort, although it's still a work in progress, that we're doing in terms of legislation, thinking about the AI Act, thinking about what California is doing. There are, for example, the California AI regulation has decided that you want to not use, there are limits on the usage of AI for hiring or for to prevent discrimination. The AI Act is even a little more strict in a sense that you make all these high risk, low risk, that there's a scale to sort of ban AI for certain usage like social scoring and manipulative techniques, as you were saying. So there's a little bit of effort from the institutions and a lot of effort that we need to do as developers of these models.
Yeah. So I know that we're at time and we're definitely going to schedule a number of follow-up conversations. I wanted to leave everybody with some of your thoughts around how businesses, organizations, industries can prepare for this new generation of human-machine interfaces, interaction, capabilities.
Well, great question. It's a new field, so still changing very quickly, but definitely the investment on R&D, the investment on emerging technologies, as companies, we should start exploring what's the meaning of AI-driven multimodal interaction. What are the best ways to interact with people through voice, through gesture, through gaze tracking, develop adaptive interfaces that leverage emerging technologies to be context aware, to be intelligent and assist through these novel methods rather than relying on traditional methods. And I would say also fostering this sort of strategic partnership with these novel AI startups that are developing the hardware, the research institution that are building the next generation interfaces. And keeping in mind what we were talking about at the beginning of this chat, that is it's important that we both educate the user, but also we include in our study, in our definition of the population segments that we want to target, not only people that are techy and capable of adapt very quickly to technology, but also creating a design that is inclusive for everybody. And of course, this includes also all the ethical conversations that we had before, like privacy, security, making sure that the AI is trustable. And the last one, just thinking about the regulatory changes that we were talking about, like the AI California regulation, there will be more coming, and we need to be ready to adapt to them.
I agree. I think that's a great list. I'm a big believer that the best technology interfaces are the ones that you don't have to think about interfacing at all, right? When your environment can sense and understand and react without your direct engagement. But at the same time, that requires a huge leap of faith and access to everything in your entire home. So there's, of course, going to be first followers. There's going to be people who are early adopters on that, who are all in. But yeah, we have a lot of work to do. So thank you so much for this. We'll be following up. Feel free to the audience to post any questions. We'll keep the conversation going on LinkedIn, and the recording will be up. So if you missed it or want to revisit it, you have it in perpetuity.
Thank you, and thank you, everybody. It was a pleasure.
Thanks, everybody.